Sure. So let's talk a little bit of Vault, huh? Let's do a little Vault talk. All right. So we've got Vault. We've got it implemented. It's becoming our single source of all of the secrets. But what's next? And how can we actually start to integrate now Vault into really our applications, right? Because at the end of the day, that's why we've brought it in, is to ultimately help with some integration into our applications. But one of the challenges is that, a little known secret is that not, and most applications aren't really, I'd say, Vault aware, right? So if you're relatively new to HashiCorp Vault, let me just give a little primer of what that looks like. So I have an application and I need some secrets. And so I will go ahead and authenticate into Vault. So Vault has all of these authentication methods that allow me to kind of prove who I am. And then once I authenticate, it gives me back a Vault token. And that Vault token now has the ability to go access some things within the secrets engines of Vault, right? And so that inherently what I've just done is kind of put a dependency in from these applications to be able to have to go in and authenticate and ultimately lifecycle this token process. And then once I have the token, ultimately, Vault's all about secrets. So let me go ahead and grab those secrets, which also introduces a bit of a kind of dependency, right? In life cycling those secrets. So HashiCorp is obviously aware of this, and we have applications that are obviously running in many different places. We have applications running in virtual machines. And so with a technology called Vault Agent, we can really simplify that lifecycle process, right? So now I can have my application, if it's running in a virtual machine, I can go ahead and have the Vault Agent, take care of all of the overhead of the authentication and the client token retrieval, the lifecycle management of that, and then ultimately the retrieval of the secrets itself, which is really super helpful, right? So now I can just write my applications. They don't necessarily need to be Vault aware, but I do need a virtual machine in order to do that. Well, we know that now all applications live in VMs these days. In fact, there are some that now live in containers. So what do I do in that situation, right? So HashiCorp has released a Vault Agent container for secrets injections, secret injection into Kubernetes. One of the things that's super useful about that is it kind of deploys in a bit of a sidecar method to inject our secrets into a container and ultimately leverage them for all of our container-based applications. What I really like about this is it uses the native auth method that's a part of my apps living in Kubernetes. So let's use the Kubernetes auth method. I really like that part of it. And ultimately, it will render my secrets and make them kind of consumable to my pods through the Vault Agent templating technology. So now we've got VMs kind of covered and we've got containers covered. But what about this other application phenomenon called serverless, right? So how are we going to do that? Well, in this talk, I want to just provide maybe some food for thought about how we can extend Vault into serverless applications. All right, so my name is Gabe Maentz. I work for a HashiCorp partner called Riverpoint Technology. I've got all the badges in the Vault and the Terraform land, and I'm really helping customers enable, implement, and adopt the Hashi stack. So why serverless? What is this serverless? Little secret. Serverless doesn't mean no server. It just means a little bit less server, right? And so this becomes a bit of a problem for Vault agents, which require us to go and do an install, right? Because a function is really built with kind of the requirement of not being able to install anything locally. Pretty popular though, because from a payment method, I just can go ahead and pay only when my functions or my code actually runs. And it is becoming relatively popular, right? Most people know what a Lambda function is, and Google has cloud functions, and even Azure has their function piece. So all the server major server cloud providers are offering a serverless kind of service. So what does that look like, right? So, you know, a serverless function might receive some type of trigger that could be from, you know, a user or maybe from an event, like a machine event. And that triggers, in this case, I'm looking at a Lambda function to maybe perform some type of action. Maybe I need to update a database, or I may need to make an API call to some other service or some other application system. Well, when I go to update that database, inevitably, that means I need database credentials, right? And so where would I go to grab database credentials? Well, no secret here, no pun intended. I'd go to Vault, right? And so this is where I'm going to go ahead and grab my credentials to authenticate to my database and perform my query or my update. So why Vault for serverless? Well, a couple of reasons. First of all, Vault is, you know, best in class at this secure storage thing, or secure secret thing. Serverless functions are relatively short-lived, right? They perform their job, they perform their task, and then they kind of stop, right? And I like the idea of Vault's dynamic secrets, which also can be short-lived and rotated and revoked if I need to. So I like that matchup of a short-lived function along with a short-lived secret, just enough to do my job for it. I like Vault because it works with all of the different major clouds that are out there, right? It has authentication for AWS and Google and Azure. And then, of course, I can centralize all of that, right? I can go ahead and centralize the auth and the logging and really just the overall management. So I think Vault makes a lot of sense in some ways for serverless. If you're new to serverless, the different functions have to run with a runtime, right? And each cloud has a different standard of what runtimes they work with. Python, Node.js, Ruby, Go, all very popular runtimes. But when I create my function, one of the challenges I have is I need to couple that runtime of my application along with something that is Vault aware, right? And so there are some well-published and used libraries for each of the runtimes that are supported in kind of the serverless ecosystem. There's a couple that are HashiCorp official. I've actually put a link to these libraries at the screen here. But there's an official Go and Ruby client by HashiCorp themselves. And then there's some well-known community ones. So HVAC for Python, Spring Vault, and Node Vault for Node.js. So I marry these two technologies together. And ultimately, what I want to do is go ahead and query and authenticate into Vault to grab my credentials. So let's walk through that process a little bit. All right. So the first step is I have to enable an auth method within Vault. And in this case, my scenario is that I'm going to be running a Lambda function. So that's in AWS. So let me go ahead and enable AWS's auth method, right? And I'm also going to enable a dynamic secrets engine for my database credentials. Once again, I want to keep those database credentials relatively short-lived. And so what I can do to do that is simply go into Vault and I can enable the AWS authentication method. Pretty simple one-liner to do that. And then once my auth method is enabled, then I have to go ahead and give it some configuration. And the configuration that I'm going to give it in this case, two pieces I really kind of want to call out, is that AWS's auth method supports an IAM authentication type. This means that I can actually bind the role that my Lambda function is running as to perform this authentication, and then ultimately attach it to a policy inside Vault, which allows me to tells me what I can or can't do within the Vault secrets engine, right? And then I also want to keep that auth method relatively short. So you'll see that I have a TTL of 15 minutes here. I believe Lambda's time out after a 15-minute run. So I'm going to go ahead and keep my auth method short to match kind of. There's no need to keep them out there for a long period of time. So once auth is set up, once my secrets engine is set up, then I need to tell my Lambda function to auth in to Vault. And it does that using the IAM auth method. Ultimately, Vault will come back and return to me a token, right? And so the way I'm going to handle that is actually using, so I've written my function in Python. And so I'm going to leverage the Python community library called HVAC. All right, so I'm going to import that into my code. And then what that allows me to do is ultimately connect up into my Vault environment. So along with my function, I've simply passed an environment variable for where I can expect to find my Vault instance. So I'm just passing the Vault address to my code. And then I'm going to use that HVAC library to go ahead and authenticate into Vault. And you can see that this is going to perform an IAM login with the credentials of the Lambda function itself. So once I get my token back, once I have a successful auth and I get my token back, you know, I got to go get my secrets, right? So let's go do that. And then I've got to go ahead and ultimately query and connect to my database. So the HVAC library supports that as well. I can generate a credential response where it's going to head and it's going to generate my credentials from Vault in a policy called Lambda-function, which I've named inside Vault. And then Vault will actually go out to my database and generate short-lived secrets. In this case, a username and a password that I can return back to my Lambda function to build a database connection string and ultimately perform my query. All right, so the way that looks, if I take a look at the logs of a successful Lambda run is, you know, I trigger my function. It will go out to my Vault server and connect up. It will authenticate using the AWS auth method. Then it will generate some dynamic credentials. It will return those dynamic credentials. In this case, I know that they're Vault generated because I have that little V dash, right? That's kind of one of the dynamic credentials for database auth that Vault returns. And then ultimately, I'm going to use that username and password, that short-lived username and password, to connect up to my database and ultimately run my query. Well, that's great for AWS and Lambda, but Gabe, like, what about the other clouds? You know, there's other ones out there. So awesome. Vault actually allows us to enable authentication for all of the major well-known clouds. So let's take a trip down into GCP. Their serverless functionality is called Google Cloud Functions, and there's Cloud Run and a number of different ones that are coming out around that world. But I'm going to continue to stick with the Python library or the Python code with my HVAC library. Just changing a few icons here, right? But everything ultimately is the same. The only major call out here is that instead of authenticating natively into AWS, now I'm in the Google Cloud. So let me go ahead and authenticate natively using the GCP auth method. All right, so this will look very similar. I'll just go ahead and auth into GCP. One of the configuration items when I enable the GCP authentication method is to provide some generic credentials for how those credentials are going to be returned back to me, right? And then ultimately, I'm going to create a GCP role in my auth method, which binds me to that service account within the Google Cloud. And once again, I've made my TTL relatively short, trying to keep everything just in time for us. So the Python code, once again, leverages the HVAC library. It goes ahead and grabs the Vault address. And then ultimately, it will go and connect to the credentials. And so GCP's auth method is a little bit different than AWS's. It first needs to generate a JOT token that will, that build out was a little funny. That it first needs to generate a JOT token and sign that token. All right. So this is just how the GCP auth method kind of works, and that's what their API supports. So, you know, I'll get in line and I'll do that, and ultimately leverage the HVAC library to perform a GCP login this time, using that role that I've defined in Vault along with the signed JWT token. That will go ahead and give me the token that I need, which will allow me to perform a read. And in this case, I'm going to go ahead and just, instead of reading and generating some dynamic secrets, I'm just going to go and read a data password in a key value secrets engine. All right, and print that out to the screen. So here's what the equivalent logs look like in Google, right? So I've got my kind of, hey, I'm here, hello world. And I'm going to go ahead and pass in that service credential, and ultimately going to return back. Now, I don't recommend you actually print your password to the screen, but you know, why not? Super secret, just to show that it is grabbing that information out of Vault. All right. So the function was relatively small to execute. Now, what's cool about that is now that those are all been built, I can actually go into Vault. So I've just connected into Vault here. You can see all my auth methods that have been enabled for the clouds that I'm working in. And you can go into the leases section, and it looks like my lease has already expired here. So let me go ahead and see if I can't generate that new lease. Let me go ahead and generate a Lambda one here. And then when that lease happens, just do a quick refresh. Now I have a database lease with creds, in this case for my Lambda, right? So they're short-lived, they're just in time, just enough for me to complete my task. And that's great. So there's a lot of runtimes, there's a lot of libraries. There's got to be a way to make this a little bit easier, right? I mean, you know, I'm coding a lot of things that are not necessarily around my application, but more of how do I integrate and connect to Vault. And while that's cool, it's not really a core thing that I want to be spending a lot of time on, right? So there is a new kind of public preview of a work effort called the Lambda Vault extension that I've been kind of keeping my eyes on, and I'm pretty excited about. So just like Vault Agent helped, you know, make non-Vault aware applications integrate with Vault, and, you know, the containers, in sidecar injection did it for containers. This Vault extension actually takes a little bit of the burden off of me to make my Lambda functions, and now this is only for Lambda at this point, right? So to make my Lambda functions a little bit more aware, Vault aware, that is. And so, you know, I can look at a bit of the handshake that's going on here, and it leverages extensions to be able to go take care of this whole authentication, token exchange, generating of and grabbing of secrets, right? And then it presents that back to my Lambda function to ultimately use those credentials to, you know, perform a query to my database or what have you. All right. So it uses Lambda's execution role to authenticate and actually do that. All right. So this is what that looks like now using this Vault Lambda extension. All right. So it actually runs and initializes before the function runtime happens. So I'm going to articulate that with a couple of different color boxes. So the Vault Lambda extension will attempt to take care of the Vault login for me. And then the runtime will get started, right? This is my Python code, which now does not have to have all of that Vault awareness kind of scaffolding put into place. And then once the extension is initialized and receives an event, then I can go ahead and the runtime can simply execute, and the extension places the secrets that I'm after just in a little temporary location that the function can go and read. You can name this whatever you want. I just kind of kept the default. And that's just vault_secret.json. So similar to what the Vault agent is doing, where it's grabbing those credentials, taking kind of that burden of the lifecycle management of all these things, and making it and placing them in a way that that my application, my function can understand. All right. So what that looks like inside Lambda itself is if I go into my function that has the Vault extension enabled, you can see that there's a layer here, which I've just simply placed into my Vault function. Or I'm sorry, my Lambda function. All right. So in summary, our goal is to always simplify the life cycle of serverless applications and their integration with Vault, right? We want to make it low overhead. We obviously have to preserve the integrity of the security aspects of things. And while Vault, couple of things to kind of design and leverage with respect to Vault is use the native authentication of the cloud that you're running in, right? So Vault supports them all. So go ahead and, if you're using Lambdas, use the AWS Auth. If you're using GCP, use GCPs. Keep your token life cycles short. Utilize dynamic secrets where you can, right? There's no need to keep these long-lived creds out there. So keep those things for an appropriate amount of time. And I would challenge you to keep them as short as possible. And really, as serverless adoption continues to kind of grow, right, we're going to need methods to keep providing credentials in an easy way to those serverless functions. So I'm pretty pumped about the Vault Lambda extension. I think that's a promising step to help, not only cover applications running in virtual machines and in containers, but also now extending into the serverless world as well. So I've placed reference materials, some links to some of the pieces that I've talked through in this talk, runtimes and the libraries that we've talked about. I'm going to check out a couple other Hashi talks as well around the serverless and container world as it relates to some of the Hashi stacks. So yeah.
Thanks, Gabe. This is a great presentation. I actually really liked how you were able to progress through different clouds. The main sort of clouds that, at least folks come to me and ask about, how do I do Vault with serverless on it? We actually had a couple questions in chat that are, I guess, more Vault general. Sure. And if you're open to answering them live.
Why not?
All right. Yeah, be brave, be brave. It's
I'll
awesome.
ask for an assist, Rosemary, if it gets too hard. But.
Of course. We'll pair together. It'll be
All right.
great. By the time we get to the end of it, we'll somewhat get the right answer.
Sounds good.
All right. So someone mentioned that they feel like they have a chicken or egg problem with, let's say, app role keys. When you have app role auth, you need the ID and the secret key. But where do you store the secret key?
Yeah. Yeah. So this is so app auth is like this kind of machine-based auth, right? It's less kind of user and it's more connect. And so, yeah, you need an app role, right, to do those. So you typically want to keep those separated, right? And so maybe you have different systems that are laying down, some configuration management system that is laying down that information to distribute it. And then you could even, auth in and get the other half, if you will, right? But it is a little bit of a chicken and the egg. That's a good scenario, right? To how to connect those things. That would be my piece on it.
Yeah, I think there are many ways to do this. Someone in the chat mentioned storing it in cubbyhole and using response wrapping. Yeah. At the end of the day, the secret key should have a similar life cycle management as any other dynamic secret. Itself, it is also a dynamic secret. So there are many ways to do this.
Yeah,
absolutely. Let's see. All right. So someone actually made an interesting, I guess, noticed something interesting, which is that when you use the Python library for AWS Auth, it uses a simple Bodo call to get the IAM credentials that gets passed to Vault. However, the HashiCorp Go library requires you to create the claim, sign the JOT, and then send it to Vault. So there are more steps involved. Are you familiar with, I guess, the differences in how these two interact?
No, I don't know enough about the Go library. It's obviously supported by HashiCorp. I've been doing most of my stuff in Python, to be honest with you. So I just haven't had enough soak time, I guess, with it to understand the differences.
Yeah. I think that the Go library, the extension that you demoed uses the Go library. And so it's in some ways the Go library is probably like the best practice, quote unquote, I guess there's a, I always put it in quotes, way to do it. But there are multiple ways.
What's interesting about the extension actually is even though the extension is Go based, it actually works with, you can use it with Python on top. That's what you just because the extension is written in Go doesn't mean the runtime has to be built in Go either. So they can be different there. So cool.
That's awesome. And I guess I have one final question, which is how do you make a decision on the time to live for secrets for Lambdas, right? Like I imagine, is it the lifetime of the Lambda? Is it the lifetime of 3 Lambdas? What kind of decisioning goes into place when you choose?
Yeah, I mean, it's going to be a little bit of a back and forth process, right? You're going to have all Lambdas have a timeout to them to some degree. I always go shorter the better, right? I just kind of have that mindset, and I use 15 minutes, but I mean, even for many people, like changing it to a day would be relatively short compared to, I've seen secrets that are out there that haven't been rotated in over a year. So I'll take the win, right? Like just reduce it a little bit, and it doesn't have to be perfect, but get a feel, look at the log pieces, see how long some of these things are running, how long the execution is happening, and make an intelligent decision based on that.
Awesome. Well, thank you so much for joining us, Gabe. This was a fantastic talk. I think I got a little overview of every single cloud, so I appreciated that.
Awesome.
Yeah, Gabe will be in the YouTube chat. So if you have any other specific questions or you want to debate the various nuances of Vault, I highly recommend you interact in the YouTube chat. And Gabe, thank you for joining us today.
Thank you, everyone. Have a great day.